In software engineering, a software development methodology is a splitting of software development work into distinct phases containing activities with the intent of better planning and management. It is often considered a subset of the system's development lifecycle. The methodology may include the pre-definition of specific deliverables and artifacts that are created and completed by a project team to develop or maintain an application. Common methodologies include waterfall, prototyping, iterative and incremental development, spiral development, rapid application development, extreme programming, and various types of agile methodology. Some people consider a lifecycle model a more general term for a category of methodologies, and a software development process a more specific term to refer to a specific process chosen by a specific organization. For example, there are many specific software development processes that fit the spiral life cycle model. In practice, a variety of such frameworks have evolved over the years, each with its own recognized strengths and weaknesses. One software development methodology framework is not necessarily suitable for use by all projects. Each of the available methodology frameworks are best suited to specific kinds of projects, based on various technical, organizational, project and team considerations. Software development organizations implement process methodologies to ease the process of development. Sometimes, contractors may require methodologies employed. An example is the U.S. defense industry, which requires a rating based on process models to obtain contracts. The international standard for describing the method of selecting, implementing and monitoring the life cycle for software is ISO, IEC 12207. A decades-long goal has been to find repeatable, predictable processes that improve productivity and quality. Some try to systematize or formalize the seemingly unruly task of designing software. Others apply project management techniques to designing software. Without effective project management, software projects can easily be delivered late or over budget, with large numbers of software projects not meeting their expectations in terms of functionality, cost, or delivery schedule. It is effective project management that appears to be lacking. Organizations may create a software engineering process group, which is the focal point for process improvement, composed of line practitioners who have varied skills. The group is at the center of the collaborative effort of everyone in the organization who is involved with software engineering process improvement. A particular development team may also agree to programming environment details, such as which integrated development environment is used, and one or more dominant programming paradigms, programming style rules, or choice of specific software libraries or software frameworks. These details are generally not dictated by the choice of model or general methodology. History. The software development methodology framework didn't emerge until the 1960s. According to Elliott, the system's development lifecycle can be considered to be the oldest formalized methodology framework for building information systems. The main idea of the SDLC has been to pursue the development of information systems in a very deliberate, structured and methodical way, requiring each stage of the life cycle from inception of the idea to delivery of the final system to be carried out rigidly and sequentially, within the context of the framework being applied. The main target of this methodology framework in the 1960s was to develop large-scale functional business systems in an age of large-scale business conglomerates. Information systems activities revolved around heavy data processing and number crunching routines. Methodologies, processes, and frameworks range from specific prescriptive steps that can be used directly by an organization in day-to-day work, to flexible frameworks that an organization uses to generate a custom set of steps tailored to the needs of a specific project or group. In some cases, a sponsor or maintenance organization distributes an official set of documents that describe the process. Specific examples include 1970s structured programming since 1969. Capgemini SDM, originally from PANDATA, the first English translation was published in 1974. SDM stands for System Development Methodology. 1980s structured systems analysis and design method from 1980 onwards. Information requirement analysis, soft systems methodology. 1990s object-oriented programming developed in the early 1960s, and became a dominant programming approach during the mid-1990s. Rapid application development, since 1991. Dynamic systems development method, since 1994. Scrum, since 1995. Team software process, since 1998. Rational unified process, maintained by IBM since 1998. Extreme programming, since 1999. 2000s Agile Unified Process, maintained since 2005 by Scott Ambler. Disciplined Agile delivery superseded of AUP approaches. Several software development approaches have been used since the origin of information technology, in two main categories. Typically an approach or a combination of approaches is chosen by management or a development team. Traditional methodologies such as Waterfall that have distinct phases are sometimes known as software development lifecycle methodologies, though this term could also be used more generally to refer to any methodology. Lifecycle approach with distinct phases is in contrast to agile approaches which define a process of iteration, but where design, construction, and deployment of different pieces can occur simultaneously. Waterfall development. The waterfall model is a sequential development approach, in which development is seen as flowing steadily downwards through several phases, typically requirements analysis resulting in a software requirements specification, software design, implementation, testing, integration, if there are multiple subsystems, deployment, maintenance. The first formal description of the method is often cited as an article published by Winston W. Royce in 1970, although Royce did not use the term waterfall in this article. The basic principles are: project is divided into sequential phases, with some overlap and splashback acceptable between phases. Emphasis is on planning, time schedules, target dates, budgets and implementation of an entire system at one time. Tight control is maintained over the life of the project via extensive written documentation, formal reviews, and approval sign-off by the user, and information technology management occurring at the end of most phases before beginning the next phase. Written documentation is an explicit deliverable of each phase. Iterate, create a prototype, then the real system. Repeat each phase using new information gained in the entire process at least once before delivering the live system. The iteration step has largely been omitted in practice due to how the methodology was taught and the perception at the time that it would be too costly for winning US DoD contracts. The waterfall model with no iteration or prototype is known as the traditional engineering approach applied to software engineering. However, it is a direct result of requirements for bidding for U.S. military contracts. As a consequence, unless part of the project plan, a strict waterfall approach discourages revisiting and revising any prior phase once it is complete. This inflexibility has been a source of criticism by supporters of other more flexible models. It has been widely blamed for several large-scale government projects running over budget, over time, and sometimes failing to deliver on requirements due to the big design up-front approach, except when contractually required. The waterfall model has been largely superseded by more flexible and versatile methodologies developed specifically for software development. See criticism of waterfall model. The waterfall model is also commonly taught with the mnemonic A Dance in the Dark Every Monday, representing analysis, design, implementation, testing, documentation and execution, and maintenance. Prototyping software. Prototyping is the development approach of activities during software development, the creation of prototypes, i.e., incomplete versions of the software program being developed. The basic principles are not a standalone, complete development methodology, but rather an approach to handle selected parts of a larger, more traditional development methodology. It attempts to reduce inherent project risk by breaking a project into smaller segments and providing more ease of change during the development process. User is involved throughout the development process, which increases the likelihood of user acceptance of the final implementation. Small-scale mock-ups of the system are developed following an iterative modification process until the prototype evolves to meet the user's requirements. While most prototypes are developed with the expectation that they will be discarded, it is possible in some cases to evolve from prototype to working system. A basic understanding of the fundamental business problem is necessary to avoid solving the wrong problems. Incremental development. Various methods are acceptable for combining linear and iterative systems development methodologies, with the primary objective of each being to reduce inherent project risk by breaking a project into smaller segments and providing more ease of change during the development process. The basic principles are: a series of mini waterfalls are performed, where all phases of the waterfall are completed for a small part of a system, before proceeding to the next increment, or overall requirements are defined before proceeding to evolutionary mini waterfall development of individual increments of a system, or the initial software concept, requirements analysis, and design of architecture and system core are defined via waterfall, followed by iterative prototyping, which culminates in installing the final prototype, a working system. Iterative and incremental development. Iterative development prescribes the construction of initially small but ever larger portions of a software project to help all those involved to uncover important issues early before problems or faulty assumptions can lead to disaster. Spiral development. In 1988, Beao published a formal software system development spiral model, which combines some key aspects of the waterfall model and rapid prototyping methodologies, in an effort to combine advantages of top-down and bottom-up concepts. It provided emphasis in a key area many felt had been neglected by other methodologies: deliberate iterative risk analysis, particularly suited to large-scale complex systems. The basic principles are: focus is on risk assessment and on minimizing project risk by breaking a project into smaller segments and providing more ease of change during the development process, as well as providing the opportunity to evaluate risks and weigh consideration of project continuation throughout the life cycle. Each cycle involves a progression through the same sequence of steps, for each part of the product and for each of its levels of elaboration, from an overall concept of operation document down to the coding of each individual program. Each trip around the spiral traverses 4 basic quadrants. Determine objectives, alternatives, and constraints of the iteration, evaluate alternatives, identify and resolve risks, develop and verify deliverables from the iteration, and plan the next iteration. Begin each cycle with an identification of stakeholders and their win conditions, and end each cycle with review and commitment. Rapid application development. Rapid application development is a software development methodology, which favors iterative development and the rapid construction of prototypes instead of large amounts of upfront planning. The planning of software developed using RUD is interleaved with writing the software itself. The lack of extensive pre-planning generally allows software to be written much faster, and makes it easier to change requirements. The rapid development process starts with the development of preliminary data models and business process models using structured techniques. In the next stage, requirements are verified using prototyping, eventually to refine the data and process models. These stages are repeated iteratively. Further development results in a combined business requirements and technical design statement to be used for constructing new systems. The term was first used to describe a software development process introduced by James Martin in 1991. According to Witten, it is a merger of various structured techniques, especially data-driven information engineering, with prototyping techniques to accelerate software systems development. The basic principles of rapid application development are: key objective is for fast development and delivery of a high-quality system at a relatively low investment cost. It attempts to reduce inherent project risk by breaking a project into smaller segments and providing more ease of change during the development process. Aims to produce high-quality systems quickly, primarily via iterative prototyping, active user involvement, and computerized development tools. These tools may include graphical user interface builders, computer-aided software engineering tools, database management systems, fourth-generation programming languages, code generators, and object-oriented techniques. Key emphasis is on fulfilling the business need, while technological or engineering excellence is of lesser importance. Project control involves prioritizing development and defining delivery deadlines or time boxes. If the project starts to slip, emphasis is on reducing requirements to fit the time box, not in increasing the deadline. Generally includes joint application design, where users are intensely involved in system design, via consensus building in either structured workshops, or electronically facilitated interaction. Active user involvement is imperative. Iteratively produces production software, as opposed to a throwaway prototype. Produces documentation necessary to facilitate future development and maintenance. Standard systems analysis and design methods can be fitted into this framework. Agile development, agile software development, refers to a group of software development methodologies based on iterative development, where requirements and solutions evolve via collaboration between self-organizing cross-functional teams. The term was coined in the year 2001 when the Agile Manifesto was formulated. Agile software development uses iterative development as a basis but advocates a lighter and more people-centric viewpoint than traditional approaches. Agile processes fundamentally incorporate iteration and the continuous feedback that it provides to successively refine and deliver a software system. There are many agile methodologies, including Dynamic Systems Development Method, Kanban, Scrum. Lightweight methodologies. A lightweight methodology has a small number of rules. Some of these methodologies are also considered agile. Adaptive software development by Jim Highsmith, described in his 1999 book Adaptive Software Development. Crystal clear family of methodologies with Alistair Cockburn. Extreme programming, promoted by people such as Kent Beck and Martin Fowler. In extreme programming, the phases are carried out in extremely small steps compared to the older, batch processes. The first pass through the steps might take a day or a week, rather than the months or years of each complete step in the waterfall model. First one writes automated tests to provide concrete goals for development. Next is coding, which is complete when all the tests pass, and the programmers can't think of any more tests that are needed. Design and architecture emerge from refactoring, and come after coding. The same people who do the coding do design. The incomplete but functional system is deployed or demonstrated for the users. At this point, the practitioners start again on writing tests for the next most important part of the system. Feature-driven development developed by Jeff DeLuca and Peter Code. ICONIX, UML-based object modeling with use cases, a lightweight precursor to the rational unified process. Other high-level software project methodologies include chaos model. The main rule is always resolve the most important issue first. Incremental funding methodology, an iterative approach. Structured systems analysis and design method, a specific version of Waterfall. Slow programming, as part of the larger slow movement, emphasizes careful and gradual work without time pressures. Slow programming aims to avoid bugs and overly quick release schedules. V model, an extension of the waterfall model. Unified process is an iterative software development methodology framework, based on unified modeling language. UP organizes the development of software into 4 phases, each consisting of one or more executable iterations of the software at that stage of development: inception, elaboration, construction, and guidelines. Many tools and products exist to facilitate UP implementation. One of the more popular versions of UP is the Rational Unified Process. Code and fix is an pattern. Development is not done through a deliberate strategy or methodology. It is often the result of schedule pressure on the software development team. Without much of a design in the way, programmers immediately begin producing code. At some point, testing begins, and the unavoidable bugs must then be fixed before the product can be shipped.